And in this picture, what we are seeing, a fellow is trying to expand a rubber band or some strip, rubber strip. The dotted line here indicates the original boundaries of the material. When he stretches it a little, the material goes beyond the actual boundary on this side and this side. But see here what it is happening, it is becoming thinner and thinner. If he stretches the material still more, right, the material becomes still thinner. Okay, so in this situation, length is increasing, right, thickness is decreasing. So length is increasing and thickness is decreasing. Have you understood what's happening here? Okay, so this simple experiment you can do in your home by just by using some soft materials like rubber or something. Well, so this can also be done in case of an eraser, right? When you press it from either ends, the eraser may expand, it becomes thicker. Okay, when you compress, the material becomes thicker, right? So under that circumstance, we define a parameter called Poisson's ratio. So what actually it is? Poisson's ratio. It is the definition what you are seeing here. It is also there in our book. It is the ratio of lateral strain. Just observe. It is the ratio of lateral strain divided by longitudinal strain. Longitudinal strain. So what is actually the lateral strain? Lateral strain is this one. Change in the thickness. Change in the thickness is lateral. Okay, so this is lateral. It is already said, the lateral. So the change in the length is longitudinal strain. Okay, so there you can express longitudinal strain. The length corresponds to longitudinal strain and thickness corresponds to lateral strain. Okay, so if you understood this one, then you can say easily say the Poisson's ratio, that is how it is the ratio of lateral strain divided by longitudinal strain. So you can also express in terms of diameter. So for a cylindrical wire, right, when you expand it or compress it, its a diameter changes. Diameter is this one, which is diameter. So diameter may change when you expand or compress. As a consequence, there will be change in the length also. So lateral strain divided by longitudinal strain, that is the meaning of Poisson's ratio. Well, now we have to know the energy stored, the elastic energy stored per unit volume in a stretched wire. So if you stretch a wire, how much energy is stored in the wire, a stretched wire? Or you can simply take this illustration for a rubber band also. When you stretch a wire, you will do some work. So that work is nothing but W, which is another form of energy. So this is in terms of mechanics, right? So that work done is half multiplied by stress multiplied by strain multiplied by volume of the wire. Okay, so don't forget this formula. W, which is work done, which is equal to half into stress multiplied by strain multiplied by stress and multiplied by volume of the wire. This work done on the wire is stored in the form of potential energy, right? So work done will be stored always in the form of potential energy in such wires. Okay, so the finally what you can say, you can also say the potential energy is half multiplied by stress multiplied by strain and multiplied by volume of the wire. So this is the standard formula that you can make use. If you want energy per unit volume of the wire, unit volume of the wire, unit wire is wrongly typed here. So potential energy per unit volume. So if it is energy per unit volume, then what you have to do? You have to divide this whole equation by V. So when you divide this equation by V, I can simply say it is by small letter U. This is half multiplied by stress multiplied by strain. That's all. So don't add V along with this equation. So half into stress into strain. So this is energy per unit volume. So otherwise you can simply say half sigma into epsilon. So sigma is stress and this epsilon is strain. So half stress into strain is energy per unit volume in the wire. Okay. So finally here is a kind of derivation. It is not necessary now to make derivation. I simply tell you the detail here. The force which is acting on a stretching wire, say this is a wire which is hooked up at the roof, and some sort of weight is hanging at the bottom, right? So this weight is pulling this wire down with a greater force mg. Okay, so the same force is also acting here. So the mg is the force which is pulling this wire down. So this force is simply F. The weight itself is F, and that force uh, becomes a kind of stress that causes stress in this wire. How actually we define stress? Here, since the length is changing, right? Since the length is changing, the length will increase when you hang this weight. So the longitudinal stress is F divided by A. This is longitudinal stress. Where is this area? This area is at the bottom. Okay. So be careful that we are not seeing. Yeah, this is the area. The area at the bottom, right? So that is the area of the wire, and F divided by A is longitudinal stress. If on a final situation we see there is a change in length and the final length becomes L plus delta L, at that moment you can define strain, that is delta L divided by L, which is strain. So now divide F divided by A and delta L by L. Okay, so that is what I did here, F divided by A and delta L by L. So that is equal to what it be? It will be F into L divided by A into delta L, right? So now use some significant letters. So the F is mg, which is the weight what we suspended here. So that is mg. Keep that L as it is. And what is A? Area of cross section. If you observe at the bottom, if the wire is cylindrical, at that moment the area of the wire is pi r square, right? At that moment I can use the area of the wire as pi r square. That pi r square comes here along with delta L. So that will be your final expression for Young's modulus. Y is equal to this one. And before that you must know any modulus of elasticity is stress divided by strain. And here we are defining Young's modulus, and Young's modulus is longitudinal stress divided by longitudinal strain. And finally we are getting this equation, which is for this cylindrical wire. Okay, so that's all about this chapter.